Assalamu alaikum. My name is Pogomu Nyanko Adema, and my matriculation is 1629851. In this video, I'm going to present to you my final year project topic, which is on smart water monitoring system for flood detection. And I'm glad to highlight that I've been supervised by Dr. Rizal Mohammed. So let's get started. Floods are quite common in Malaysia, pretty much consistently, and this peculiarity or phenomenon occurs by causing different infrastructural damages, and sometimes it may cause loss of life. So this study or this project subsequently expect to carry out a water monitoring system that forecasts flood happening on a heavy rainfall using a remote telemetry unit or called RTU, which is actually interconnected with some sensors, such as water sensor, water level sensors, pH, temperature, and so on, in order to capture the data and send them on the website that is built for this project for data visualization and for decision making of further actions. So let's get to the problem statement. Why did we choose this topic? Why? The why of this topic. So basically, flood disasters have brought several impact on the people lives, damaging properties and infrastructure, and even taking lives away. About millions of ringgit are spent every year in order to recover from the loss or damages caused by the flood in Malaysia. So let's look at the objective of this project, the main objective or the target that we want to accomplish in this project. First of all, we want to develop the information technology knowledge related to the real-life project development. And secondly, develop an IoT network system through a secure real-time water monitoring system. And the third point is to give the ability to the users of this system to be notified through SMS when a flood is being detected. So let's look at the methodology used in this project. For the implementation of this project, we actually look for the software development lifecycle, or called SDLC, as a methodology, since it's look into every step of the development and can be monitored and accept changes over the development of the system. So let's look about the procedure that we use or the infrastructure to make this project successful. So basically, we interconnected the sensors that we need to in order to collect the data to the RTU, which is provided by Jua Corporation SDN Berhad. So this RTU is composed of Raspberry Pi interconnected with sensors, and the RTU, we therefore get it connected to the IoT gateway and collect data and send it on a REST using REST API to the server or the website or the official SWAM website, which stands for Smart Water Monitoring System. So let's look at the experiment setup. On the first picture, you can see the composition of the RTU, and it actually composed of Raspberry Pi interconnected with sensors and an LCD here in order to display on the LCD the current reading. And then the second picture is about the data collection from this RTU and outputting here for visualization and then transmitting to the server. So the third picture is the whole implementation, the RTU with the tank, and in this green tank here, this is where we put the water in order to text the system and capture the data to be sent to the server. So about the interface and the results, I'm going to show you from the SWAM website. All right, so here we have the SWAM website, Secure Water Monitoring and Management System. So on the dashboard, we can see the readings of the sensors that we used along the project. The water level here, as you can see, the water level from the last reading I did in campus was 17.54 meters. So we can also have a look on the reports here. We have the report where we have all the sensors listed up. And then from the date we can choose, because let's take last month, January. So you can see here, we have our RTU located in Gomba campus. And then it read the data, the water level that we put in the tank, and with variations, we have different water level here. And the time they were captured are also recorded on the website. So this same goes with the other sensors as well. When we take for the alarm, we have here for the battery, temperature. Let's look at the temperature from January. Okay, the battery. We have the data here that we connected, the temperature. We also have the data for the temperature in degrees Celsius. So basically, this is how the data are being collected and kept in the server. And we can also export these data here in PDF file or Excel file for other purposes. So let's come back to the dashboard. In this dashboard, we have an option to see the variation or the data collected in form of charts. So let's see from the time series chart or the water level. We can see how during the testing, the water level was varying, was going from variations. The time recorded is here, just down. Alarm. Alarm also is represented. The battery, about the power. We have also how the battery power was varying from stage to stage. And then the temperature. Also, the temperature was varying, and at the maximum was 30 degrees Celsius. So basically, these are the results from the readings made from the RTU to the website here, and for further actions. So let's come back to the current reading here. As you can see, the last reading was 17.54 meters, and it shows that this is at the very dangerous stage, and the indicator is actually at the red point, which means it's at a danger stage. And we can see the battery power level here, which is 11.9 volts. The temperature at the time, 25 degrees Celsius, the pH value of the water, the turbidity, and so on. So let's come back to our poster. Okay, so I just presented the interface and the results of our work. So let's look at the tools used along the development of this project. So we actually code the sensors in Python language, interconnected with a Raspberry Pi, and we use Visual Studio to do this part of the coding in order to let the sensors know what they actually supposed to do, what data to collect, and then send those data via MQTT. And regarding the website, the Swarm website, these are the tools that were used: React, PHP, MySQL, and PhysioChat in order to make it how it looks like. So in conclusion, the implementation of this system is very crucial and important innovation that can participate in preventing loss of lives and infrastructure from flood disaster. It can be monitored everywhere if there is an internet connection. However, it can send messages notification for non-online users through SMS as warning signal. So for future work, such as the implementation of relevant solutions to curb or reject the flood happening, would make the project more worthy and interesting. Thank you so much for watching this video. That's all from me.